Hi, Math 3 students. So we're going to go ahead and get started on the 6-3 task here. Real quick, we're actually going to start our 6-3 task at this point. It's in part 2, and we're going to start at the, let's see, it's on page 13. So it says, we begin with a circle of radius r whose center is located at the origin on a rectangular coordinate grid. We represent an angle of rotation in standard position by placing the vertex at the origin, the initial ray oriented along the positive x-axis, and its terminal ray rotated theta degrees counterclockwise around the origin. When theta is positive, and clockwise when theta is negative. So you go counterclockwise when theta is positive, clockwise when theta is negative. Let the ordered pair xy represent the point where the terminal ray intersects the circle. Okay, so I'm sure you were listening to that and you're like, what is this lady talking about? Okay, so let's kind of talk about all of these different words and what they mean. So the initial ray, that's this guy here. Okay, that is along the positive x-axis. That's where the initial ray goes. Then you have the terminal ray. Okay, so the terminal ray is this guy here. So rays are just rays. If you don't remember what a ray is a line that goes in one direction. Let's see, will it give me a ray? There we go. So that's a ray, right? And let's see, it says it is okay, so it's rotated counterclockwise when theta is positive. So if we take a look, clockwise is this way, right? Or I'm sorry, counterclockwise, I apologize. So it's rotated counterclockwise when theta is positive. So counterclockwise is going to be this way, all right, which makes sense. So they're showing we're starting here, we're going counterclockwise, and then we're ending here at our terminal ray, all right? And then the x and the y value represent a point on this circle. So if we were to kind of examine this triangle here, okay, this guy right here is your x value, and this guy right here is your y value, right? Because this point is x units this way, y units this way. So your side here, your adjacent side is your x value, and your opposite side of theta is your y value, all right? Let's see, in this diagram, angle theta is between 0 and 90. Okay, so let's kind of talk about that real quick too. The way that the degrees work on this is they go 0, 90, 180, and 270. Okay, I would label that. So you can see here that theta is between 0 and 90. Let's see. Therefore, the terminal ray is in quadrant 1. So if you remember the quadrants, we got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Let's see. Similar to the right triangles we have drawn in the Ferris wheel tasks, right? So these triangles look very similar to what we did in task 1 here, right, where we drew different triangles in this circle. So it should look kind of familiar here. All right. So based on this diagram and the right triangle definition of a sine ratio, find the expression for sine of theta in terms of x, y, and r. Okay, so if we look here, if we're trying to find sine of this, I'm just in a different color. If we're trying to find sine of this value, right? We know that sine is opposite over hypotenuse, right? Well, our opposite side is y, and our hypotenuse is r. So it's going to be y over r. All right. We will use this definition for any angle of rotation. Let's try it out for a specific point on a particular circle. All right, so let's try this out here. So they said, consider the point negative 3, 4, which is on the circle x squared plus y squared equals 25. So I don't believe you guys know how to graph a circle. So we're going to go to Desmos and give it a shot here. So we get x squared plus y squared equals 25. Ooh, I plugged that in wrong. Let's see, where is the equal sign? Okay. All right, so there's our circle, and this is how we're going to graph it. So actually, let me pull up then this, and we should be able to graph this on here, right? So we go through 5, 5, 5, and 5. And in case anyone's wondering how you graph this without using Desmos, minus h squared plus y minus k squared equals your radius squared. This is the general form of a circle. To find the radius, or I'm sorry, to find the center, you do h comma k, so you flip the signs here. H and k are 0, so your center is 0, 0. And then to find the radius, you take the square root of this. So your radius here would be 5. So that makes sense because our center is at 0, 0, and our radius is 5 here. Perfect. So it asks for what's the radius of the circle. That's going to be 5. And it says draw a circle and the angle of rotation showing the initial and, oh, okay, so they're looking for -3, 4. So we're going to go 1, 2, 3, 1, 2, 3, 4. All right, very nice. So let's see. Draw the circle, the angle of rotation, and showing the initial and the terminal ray. Okay, so our initial ray is going to be here, right? This is our initial ray. And then your terminal ray is going to be this guy here. Right? Because we started there and we went over to this point. So this here is theta. All right. Let's see. For the angle of rotation you just drew, what would the value of the sine be if we were to use the definition we wrote for sine in question 8? So if we look here, we have to create a triangle here. Now, if you recall, when we did the Ferris wheel one, we drew triangles like this, right? So this is our actual theta of interest right there. And then what we're going to do is we know that this value here is going to be my y value, which is 4. This value here is going to be 3, or it went in the -3 direction. And then we know that our radius is 5, right? So we should be able to figure out theta, okay? So we could do sine of theta equals, and we're going to do our opposite over our hypotenuse. Well, our opposite of this value is 4. And then we're going to put it over 5, all right, because that's our hypotenuse. It says, what is the measure of the angle of rotation? How did you determine the size of the angle of rotation? So in order to figure out what this theta right here is, we're going to do sine inverse of 4/5. All right, when I do that, oops, we get 53.1. All right, so that gave me, I know, I feel like I got so much going on here. We got that this guy here is 53.1, okay? And they want to know the angle of rotation here. So that's actually this guy. Well, if we know that this guy here is 53, and they end up making a straight line, to find the value of this, we just have to do 180 minus 53.1. All right, so when you do that, oops, 180 minus 53.1, you get 126.9. So we were able to figure out the value of this guy is 126.9. Is the calculated value based on this definition the same as the value given by the calculator for this angle of rotation? So what they mean by that is we just, what we can do is we're going to find our sine value for 126.9. Okay? So let's go ahead. We're going to do sine of 126.9. And that gives me 0.7996. And you're probably like, well, what does that mean to me? Well, we said that sine of this theta should give us 4/5. Well, what's 4/5? We get 0.8, which obviously we did some rounding here. So 0.7996 is about 0.8. So that checks out. All right. Okay, let's go ahead and try another one. So if we were to go ahead and graph this, now the center is still at 0, 0. So we're going to plot that there. Now, to find the radius, you have to take the square root of this guy. So the radius is actually going to be root 10. So what you could do is you could get the decimal value of that so that you can plot it. So you're going to plot around 3.1. So you'll go 3.1 this way, 3.1 this way, 3.1 this way, and 3.1 this way. I did 2.1 down here. There we go. Then we connect those guys. Let's see if it gives me a circle. It does here, looking good. All right. And it says draw the circle and the angle of rotation shown by the initial and terminal ray. So we've got -1 and -3. So let's go plot that on here. We're going to go -1, -3. So that'd be right here. Okay. So our initial ray is still going to be this guy, right? And then our terminal ray, though, now is going to be this guy. All right. So we went all the way around, right, for our rotation. So now it says for the angle of rotation you just drew, what would be the value of the sine if we use the definition we wrote for sine in question 8? All right, so let's go ahead and write the x and the y values here, right? So, and our radius. So we know our radius is root 10, right? And this guy is -1, -3. So we go -1, -3. And if we look back at our definition, right, we said y over r. So we're going to say sine of theta equals y, which is going to be -3, over our r, which is root 10. Okay? So if I were to plug that in on -3 divided by root 10, are you going to work? There we go. I get -0.94. So keep that in mind. Okay, actually we'll do 9486. We'll keep a couple more to be more accurate. All right. Then it says, what is the measure of the angle of rotation? How did you determine the size of the angle of rotation? So we said that sine of our angle of rotation, so sine of theta, which is this guy here, right, is going to be -3 over root 10. So what we can do is we're just going to do sine inverse of that. And that is going to give us oh, I forgot another. Is this working? There we go. And that is going to give us -72 degrees. Okay, so we got -72 degrees. So this value, ooh, didn't mean to erase. This value here is going to be 72 because we go down 72 degrees. Now, the actual angle we're interested in has to go all the way from here around. This here is 180. So you just do 180 plus 72. And that is going to give you 252. All right. And then it says is the calculated value based on this definition the same as the value given by the calculator for this angle rotation? All right. So we said that sine of theta is going to give us -3 over root 10, which we said is equal to 0.9486. Well, let's type in sine of 100 And I'm sorry, 252. Let's check if we did it right. Sine of 252 gives me negative 0.95, which is real darn close. That would just be a rounding error. We rounded this to the nearest whole number. So yeah, it works out.